Here's a tutorial on the significant figures and scientific notation quiz. This is just one version, but they both work the same way. How do we know how many significant figures are in this? Well, we said trailing decimal zeros do count, and of course anything that's not a zero does count. So this is 1, 2, 3, 4 significant figures. Leading in zeros do not count. So this is 1, 2, 3, 4 significant figures. And you said intermediate zeros do count, so that's 1, 2, and you know what? That is wrong. That is 3 significant figures, isn't it? Also, I should make the point that a number like this only has 2 significant figures because trailing zeros before the decimal, there's an invisible decimal right here, right? Trailing zeros before the decimal do not count. So that leads me to the description here. And I'm not going to write these down because I don't want to just be copied. I want people to absorb the answer and understand. I got some good answers and quite a number of bad ones, some of which made me think that the person didn't even really understand the question. You don't have to quote me, but just get the right type of answer, get the right point. The point is the point and not quoting me. We're not writing a dictionary. You don't have to say it exactly like I do. Describe how to know how many significant figures are in a number. Well, everything's significant except we said leading in zeros to the left and trailing zeros before the decimal. I think that can work. By the way, I'm not going to be slowing down that much. You can hit pause, you can hit rewind anytime you want. So if you need time to think, write stuff down, just hit pause. Put these numbers into proper scientific notation. I was not very picky about the zeros at the end because we didn't talk about that much, but to be picky, these zeros I said were not significant because trailing zeros before the decimal are not significant. I think I didn't make a very big point of that before, sorry, but for these problems, I didn't really count on that anyway. My point is, where does the decimal go? It goes after the first non-zero, so the decimal ends up here. And how many places did it move? 1, 2, 3, 4, 5. Moved 5 places, so this decimal isn't really here. It's really, and remember this means times 10 to the power of, so this is also 8.205 times 10 to the power of 5, that's an x, that's a terrible x, times 10 to the power of 5 kilograms. This decimal is not here. It's 5 spots bigger than what I'm showing you. That will get you this number back. 5 spots bigger than sitting here. Where does this decimal end up? It ends up here after the first non-zero. Where is it really? Is it really here? No, it's 4 spots smaller than I'm showing you in meters. Where does the decimal go after the first non-zero? Is it really here? No, it's 2 spots smaller than I'm showing you, times 10 to the minus 2 grams. Describe how to use scientific notation numbers. And again, I'm not writing a dictionary and I'm just speaking here. The point is to get the point. You don't have to quote me, and if I say it 3 different ways, then the point is to get the point, right? You don't have to pick one way, just get the idea. How do we use scientific notation? And I'm going to say, I got some answers that said like to make numbers shorter. It says how, not why. We put the decimal after the first non-zero, and the exponent on 10 tells where the decimal really is. Positive exponents mean it's actually bigger than this. Negative exponents means it's actually smaller than that. I think that's good enough. That works for me. On 7, to get the proper number of significant figures or significant digits, same thing. We line up the decimals back like in 5th grade. We add it up. But remember, what's here? An unknown. What's here? An unknown. What's here and here? An unknown, right? So we round off so that we don't have any columns that had unknowns in it. In this case, that's the second decimal column. We will round that off, and 3 goes down to 2. It rounds down. I keep the 2. I do not round this up to 3. I just punched this in the calculator, and you know what? I realized that this is wrong because that's what the calculator, you know what? I'm going to do this. This is what the calculator told me. But how many significant figures do I get? Well, the point is you get as many as the smallest number of significant figures in your data. So I get two significant figures. Even this is wrong because that is three significant figures. So it's really just 13 because that is two significant figures. And it's centimeters squared, although I didn't get picky about that because I'm going to wait until I remember to say I'm going to be picky about that before I'm picky on that. I punched this divided by that into the calculator, and I honestly don't remember what it said, but how many significant figures do I get? This has three significant figures, this has four, so my answer gets 3, and I rounded to 3 significant figures. Meters squared over meters cancels out to just meters. When I subtract and add scientific notation, I need the exponents on 10 to be the same, and it's easier if you'll take the smaller one and make it be bigger. -3 is smaller than -2. It's farther from 0 on the negative part of the number line. This is smaller than that. A phrase that I like to repeat and repeat and repeat until kids start kind of shouting it back at me is bigger is less negative. If bigger is less negative, then smaller is more negative, or bigger is less negative. Both are true. So which one's smaller? That one. So I'll take this and I'll make it times 10 to the minus 2. But what I did here is I multiplied by 10 to get this to be times 10 to the minus 2. If I'm going to multiply by 10 in one part of this number, I must immediately divide by 10 or I've changed the value. And changing the value is illegal. That's actual cheating. I know I tease about I'm going to cheat this and so forth, but that's actually cheating. That's changing the number. If I did that to a paycheck, that would be actually illegal. It's actually changing the number. It's not just rewriting, it's changing it. Now that these are the same exponent, and remember this gets divided by 10, so it turns into this, I can subtract, and these just fall down, kind of like any unit would. Chairs minus chairs is chairs, or apples minus apples is apples. In this case, we get something very similar, except that 3 is smaller than 4, so how about we make this into 4, this exponent here. If I multiplied by 10 to get this changed, I must divide by 10 to get this changed, and then I can add. Oh, also, this 0 is not really there because I don't know the second decimal on here, do I? So I round that off. I don't know the second decimal on here, do I? It's an unknown, so I don't really know the second decimal on my number, on my answer. This one I can do in my head. 3 times 9 is 27, and when I'm multiplying scientific notation, I add them. 7 plus a minus 4 is positive 3. Now, that's not truly good enough yet, is it? Because we said scientific notation uses the decimal after the first non-zero, so the decimal does not remain here, it goes here. Now, I actually have to say this out loud in my mind still after teaching it about 1,000 times. What just happened between here and here? This got smaller. So to compensate, the other part must get bigger. And I suggest you actually say it that way because I get lost myself unless I say it out loud, in my brain at least. This got smaller, so this must get bigger by 1 decimal point. I punched this in the calculator, and I don't remember what it said, but what's our significant figures? 3 and 3, so my answer will have 3. And I think it actually gave me 28.3 times, let's see, when we divide, we subtract. So minus 6 minus a minus 2 is positive 4. Oh no, it comes out right to this. It comes exactly out to this. You just need to know to round to 3 significant figures. Because minus 6 minus a minus 2 is positive 4. Or you can just punch the whole thing in the calculator. Why do we have to round off the adding and subtracting answers most of the time? And I got a bunch of answers, including some ones that made me a little cross-eyed. And I know I said this before. My point is that we have to round off the columns that have unknowns in them. And there usually is a column with an unknown because the decimals don't match in length, do they? And this one goes 3 decimals out, and this one only goes 1. This one goes 1, and this one goes 3. So we have to round off the columns to the right that have unknowns in them. How do we know where to round when doing multiplication and division problems? Because we look at our data given and we count the significant figures in the data. So our answer needs to have the same number of significant figures as the smallest piece of data, as the significant figures in my smallest piece of data. Or to probably even say it better, my answer will have the same significant figures as the smallest number of sig figs in my data. So for here, for instance, let's see here. This one I had 3 and 3, so the answer is in 3. I had 3 and 3, so the answer is in 3. I had 2 and 2. Excuse me, that's adding. Here we go. Here's the multiplying. I had 3 sig figs in my data and 2 sig figs in my data. So my answer needs to have 2 sig figs in the answer.